during the week because of work and everything, so we had to move the meeting to Saturday. So everyone, again, once again, welcome to ENC meeting. So I'm going to be introducing the speakers one by one, and like I know most of us might actually know be familiar with some of the speakers, and some of the speakers we are not familiar with them. So I'm just going to do a brief description of them. So I'm going to start with Zain, Muhammed Zain. I can't pronounce the third name. Sorry, Muhammed. But we have Muhammed Zain on this call. So he's an Elixir developer focused on building scalable real-time application and phonics live view and distributed system with a strong emphasis on performance, resistance and fault tolerance architecture. So he's going to be sharing his experience with us, and I hope all of you have your pen and paper, because you are going to leave here with more enlightenment on how to build a fault tolerance system. I'm going to say this is the biggest meeting we have had since we started as a community. Most time we always have one speaker, but in today's meeting we are going to be having 4 amazing speakers sharing their input on how to build a fault tolerance system. So thank you, Muhammad. We are glad to have you here. Did I miss anything, Muhammad? Okay. So we have Tai. I don't know if his name is Ta. Ta, can you pronounce your name? I don't think I'm pronouncing it well. Is it Ta? Wait, I think I might just go with the Abid. Abid. We have Talha Abid here. Is also a full stack Elixir developer with 5 years of professional experience building scalable and reliable web application using Elixir and phonics framework. Passionate about backend architecture, distributed system, and sharing knowledge with Elixir community. We are actually very glad to have you here, and thank you for accepting the invite. And we have Stacey. Before I'm going to talk about the last speaker, which is Andrew, we have Stacey here. So Stacey is currently, I don't think she has currently joined because she's trying to set up her system. But Stacey Ndela is a backend developer with a focus on Elixir and building efficient, scalable application, interested in AI, automation, and creating impactful software. So after this call, you can connect to any of these speakers on LinkedIn. So after this call, they are going to be sharing their LinkedIn profile, so you can connect with them and ask them questions or interact with them. And we have Andrew Okoye, who is our last speaker. He's a seasoned software engineer who transitioned from Node.js ecosystem to become a deep practitioner and advocate of Elixir and Beam ecosystem, specializing in highly concurrent, resilient backend system. So thank you all. That is our 4 speakers for today, and I really would say no one is going to leave here without gaining any knowledge. So I am the moderator. I think everybody already know me. So if you don't know me, I'm Ijeoma Benedicta Uwabunkeonye. I'm just a very passionate developer, and I'm very interested in the Elixir ecosystem and building scalable and efficient software. So thank you all for having me here. So we are going to kickstart. Okay, so the way I'm going to ask this question is I'm going to ask a question and I'll throw it open to all the speakers. So each of them will share their input one by one on what they think about that question and share more enlightenment. So are we ready? Hello everyone.
Yes, I do.
Oh,
Yes, I hear you.
okay. Okay, so I guess we can kickstart now, everyone. So my first point of discussion is, when you hear the term fault tolerance system, what does it mean to you, and why is it important in modern software development? So who wants to start on it? Like, or should I type it on the general group?
I think the way you are taking it is fine.
Okay.
So when you throw the question, you call name or anybody can just
No,
go first.
any of the speaker can immediately start with their own point of view.
Okay, right. I think I will go first. So my name is Andrew Nature Okoye. So when I hear fault tolerance, and what comes to my mind is the ability for a system to recover when there is a failure or an error. And basically, machines can have errors, software can have errors, no matter how careful you are as a developer, no matter how careful you are as an engineer, errors are bound to happen. Even if the error is not coming from your code, it might come from conditions not being consistent. Talk about things like network, talk about things like writing to a disk. Issues can happen. Issues we didn't anticipate to happen. They can happen. So fault tolerance is when these issues happen, how does your system respond? Do your system just stay down, or do your system um, throw out an error to the client, or do your system automatically picks up from there and restart? So fault tolerance, out of all these options I mentioned, fault tolerance is how resilient your system is when things don't go the way you planned it to go. When things are not going the happy way, how does your system respond? The more resilient it is, that's what fault tolerance is all about. So that's my own understanding on the topic.
Thank you so much. Thank you so much. So, who wants to contribute? Zain? Zain, what's your input?
Yeah, sure. So, so for me, fault tolerance is the transition from preventing errors to managing their consequences. Yeah, so in modern software, especially when building distributed systems, you have to accept a fundamental reality. Everything will eventually fail. Network requests will time out, external APIs will drop, and nodes will go down. So if your system is built on the assumption that components will always be healthy, a single failure becomes a total system outage. So for me, fault tolerance is important for maybe 3 to 4 core reasons, which I have implemented entirely in my career. First one is isolation of failure. Second one is self-healing systems. And third one is business continuity. Because if there is a business, then the developers can work. So the first point, isolation of failure, it ensures that a crash in one isolated component, like a single user session or a specific background task, doesn't trigger a cascade that brings down the entire application, right? So in the Elixir ecosystem, we use process isolation to ensure that a failure is one worker stays contained. And the second point my was self-healing system. So it shifts the burden of recovery from the developer to the runtime, right? Our system is fully fault tolerant when it can detect the crash, clean up the resources, and restart itself to a non good state without human intervention or downtime. Third but not the least, my point was that business continuity. So, in a world of real time applications, uptime is a competitive advantage. So, if your system can lose a node or encounter runtime error and the end user doesn't notice a service interruption, here you have got the success in building a resilient product. So, for me, essentially, it's about building a system that remains useful even when parts of it are broken. Yeah, that's it.
Thank you so much. Thank you very much, Zain. That is a very, very elaborate answer. Thank you so much. Taha, what's your viewpoint on this first topic, this first point of discussion?
Yeah, I'm totally agree with Zen and usually other speakers. according to me, the fault tolerance system is very important. The fault tolerance means expecting failures rather than treating them as an expectation. The goal is not build software that never fails. That is unrealistic. The goal is to build software that continues serving users even when individual components fail. In today's distributed system, where we depend on cloud infrastructure and third-party services, that ability to recover quickly and minimize user impact exceptional. So this is this is especially important in modern software because users expect application to be available 24/7, or whether it is banking app, an e-commerce platform, or a messaging service. Downtime directly impact user trust and business outcomes. So, as an Elixir developer, fault tolerance has shaped the way I think about software. OTP encourages users to isolate work into lightweight processes, supervise them, and recover automatically when something goes wrong. Rather than trying to prevent every failure, we focus on making failures small, contained, and recoverable. I think that is the key mindset behind building realistic system. Thank you.
Th- Thank you so much. Thank you so much, Zain. That's actually very very nice. Thank you so much, Stacy. Thank you for joining us, and we are glad to have you here. So we started the discussion, and I have introduced you to the team. I think everyone on this call will have heard me mention Stacy and who she is. So Stacy, would you like to take us on your viewpoint in the term fault tolerance and what it means to you and its importance to modern software? Hello, Stacy. Hi, Stacy. Can you hear me?
I can hear you.
Yeah, yeah. I
Okay.
think I can. Yeah.
Okay. Thank you so much. So I was asking, can you enlighten us and share your viewpoint on the term fault tolerance and what it means to you and why it's important in modern software development?
As to my say, I think Fault-Tolerant, we might say it's designing system that will accept, that will expect failures and continue operating without being disrupted. Since failures, like, we cannot stop failures totally, but if you build a system that expects the failure, when the failure comes, it just continues with its operation. I think that's false tolerance in simple words.
Thank you. Thank you so much. Thank you very much. I think everyone has shared a very, very beautiful intake on it, and I think it has really, really covered up the term fault tolerance and what it means. So I'll get to the second point of discussion. From your experience, what are the key principles or design decisions that make a system resilient to failure? We all know fault tolerance is about a system resisting failure. So what would you say are the key principles or design you have implemented or you have seen other system implement that makes it resilient to failure? Sorry, did anyone get what I said?
Yeah.
Okay, so Stacy, do you want to start?
I'll pick up from another one.
Okay,
Someone to
so please, who wants to
hello.
start? Okay, who wants to start the discussion?
Can you hear me?
Yeah, I can hear you, Nature.
Okay. I was just doing the ladies first mantra, as a gent and
Okay.
all. But it's fine. Since you said you don't want to go first.
Okay.
Also, I believe you're asking for the properties of the fault-tolerant system. I think the speaker that went after me touched on that. When he mentioned self-contained and like the ability that when a system is down, it will affect all components of the system. The particular component that is having issue, that error to just be contained within that component. So self-contained is one of the properties a fault-tolerant system should have. And also, I'm trying not to use Elixir keyword, but I think it's impossible. But the idea is that fault-tolerance also depends on supervision because the system needs to know when a component is down. So when a system knows that a component is down, it's more like an event kind of something. When something happens, an event is fired so that system will know that something just happened. So systems need to know that the component is down and try to restart that component. I think these are the two properties that a fault-tolerant system should have. That isolation, self-contained, and supervision. The ability for a system to know that the component is down and restart it.
Okay, thank you.
Yeah, that's it for me.
Thank you so much. Yeah, I think Zain actually mentioned some of them. So Zain, would you like to enlighten us more on what are the, you said you talked about the ones you implement. So do you would you like to enlighten us more on others that you feel that are the key principle or design decision that make a system resilient to failure? So if you want to build a fault tolerance system, what are the design principles or key
Yeah.
decision we should look into?
Yeah. So for me, the biggest principle for Zile is designing for failure instead of assuming everything will always work. So some practices I rely on are isolating failures. So one component doesn't bring down the entire application. And the other one is keeping components loosely coupled. Here, loosely coupled means to the components depend as little as possible on each other, making them easier to change or recover independently. For example, the notification service can fail without stopping the user to log in, right? And other points are having proper supervision and automatic recovery. And other point is monitoring and observability, so problems are detected early. And further, graceful degradation, where the application continues offering essential functionality, even if some features become temporarily unavailable. So in Elixir, OTP gives us many of these building blocks through process and supervision trees. Yeah. So
Thank
this
you.
is how.
Oh, okay, Zane. Thank you so much. I think that was a lot of points you dropped down. I don't know. I don't know. I've been jotting down. I hope every other person in this call is jotting down one or two key things because this call is supposed to, like, when you live here, you are supposed to be thinking in the aspect of building, like, you're supposed to be confident that when you want to build a fault tolerance system, you know what to put in place. So we are going to move to Ty. Ty, can you give us your viewpoint?
Okay,
Hello.
so
Okay.
from my experience, resilience starts with accepting that failures are a part of building distributed systems. To adopt that mindset, your design decision naturally change. And it includes a few points. The first one is an isolation principle of isolation, in which a failure of one component should not bring down the entire system. In Elixir, process isolation makes this very natural because each process is independent. Each process has own memory, and so if one crashes, the other continues running. And the other one is automatic recovery. Rather than relying on someone to start a service at 2 a.m., the system should recover on its own whenever possible. OTP servers are a great example of this. They detect failed process and restart them automatically. And we have a 3 to 4 strategy in supervision tree also. So we can adopt anyone if you want.
Th-
And another important principle in designing for external failures, APIs, database, and network will eventually failure becomes slow. So it's important to use sensible timeouts, retries with exponential backup. and circuit breakers where appropriate. And that prevents one failing dependency from affecting the entire system. So finally, I would say simplicity is underrated in my experience. Simpler system with clear boundaries are much easier to reason about, maintain and recover than high coupled overly complex architectures.
Th-
Thank you.
Thank you so much. Thank you very, very much, Ty. That's a very beautiful approach. Thank you so much. So we'll move to the lady in the house, Stacey. So, Stacey, what's your viewpoint on this?
Well, I thought by saying that you can't avoid failure, like failure is unavoidable. And one principle, I'll repeat what they've said. The one I had isolation. That's where you isolate you shouldn't put the entire system in one point. And the Elixir works out in that each process is isolated. So it's a good design and you can make decision easily. And my other point is monitoring and observing each time. When you build a system, you must monitor it and observe it, whether in teams, whether alone. I think that makes it easier and makes the system resilient to failures.
Wow, thank you so much. Thank you. I think everyone has spoke beautifully on this discussion over here. Everyone has spoke beautiful on this topic. So we are going to move to the third question. So I know most of us here have built production ready made system when it comes to Elixir. So I want, like, if two or three of the speakers that, or if every of the speaker who have built a real world have built a production application and have experienced a real world incident where your system experienced a failure, how did your team respond and what lesson did you get from the failure? So who would like to go first? Hello, wonderful speakers. Okay, so who is going first, please? Zain.
Sorry, I just missed your question. Can you?
Okay, so my question is that in a situation, or when we talk about reward experience, I know most of us have used, or most of us are still using Elixir or any functional programming language to build a reward system that user experience or user uses. So in a real world incident where your system experienced a failure, how do your team respond and what lesson did you take away from it?
Okay, yeah. So the biggest principle, in my opinion, is designing for failure instead of assuming everything will always work. So some design principles rely on failure isolation, losing coupling, supervision automatic recovery, observability, redundancy when it's matter. But since I work primarily with Elixir and OTP, these principles come quite naturally. So OTP always encourages building applications from many small isolated processes supervised by supervision trees. If one process crashes, only that process is restarted rather than affecting the entire application. So I think resilience is not about preventing every failure because that's impossible. It's not about building systems that can detect failures quickly, recover. It's about building systems that can detect failures quickly, recover automatically, and keep the user experience as uninterrupted as possible.
Okay.
So, yeah, that's my point here.
Oh, okay. Thank you so much. So I got your point, but I was trying to ask that in your application you're
Yeah,
building.
so, but yeah,
Yeah.
sure, yeah. But for real time application, there was a game which I have worked on, and that game was related to a famous game called Rung. A real multi. It was a multiplayer game. So in this, every game was managed by its own Gen server process. Sometimes players disconnected unexpectedly because of network issues or simply closed the app. So instead of treating that as a system failure, so what I designed that the game to handle it gracefully. We added in inactivity timers, automatic board players to replace inactive users, and recovery logic so the game could continue without affecting the other game sessions. So the biggest lesson was that for me, user behavior and network failures should be treated as expected events, not exceptional ones. Designing for those situations upfront makes the system much more reliable.
Thank you so much, Zain. Thank you very much. Okay, Ty, moving on to you. What can you say about that particular an incident that you faced? Probably it can be a private project or your own project, and it got like you're having a system failure or something happened. So how did your team respond, and what lesson did you learn from it?
Okay, so I remember one incident when one of our express service started responding very slowly during the peak traffic. Our application depended on that service for processing requests, and because the responses were delayed, our workers start building up increasing response times for users. So really, our real users affected too much. The first thing we did was assess the impact using our monitoring dashboards, and we always use color for error logging. So we have two logs the error. I checked that logs and matrices. We confirmed that our application itself was healthy, but the external dependency was the bottleneck. To stabilize the system, we did use the pressure by enabling stricter request timeouts and temporary timing retries. And once the service recovered, we investigated what happened and realized our integration was too dependent on that external service responding quickly. We improved the design by introducing better timeout configurations, exponential backup for retries, and fallback behavior. So one slow dependency would not affect the rest of the system. We also added better monitoring and alerts to detect similar issue much earlier. The biggest lesson for me was that you cannot control external dependency, but you can control how your system behave when they become slow or unavailable. Designing for graceful degradation and having good observation made a huge difference for me.
Thank you so much. Thank you so much. So Stacy, can we hear your point on that? And we have a question in the chat, so I'm going to read it out. But before then, can we hear your own viewpoint on it?
Yeah, so one of the issues I think is database becoming overloaded due to sudden traffic. And rather than every request to fail, resilient systems may temporarily queue the incoming request or limit traffic while the primary database recovers. And an example is there's a system we built like, okay, as I mentioned or not mention, can I mention right now?
Okay.
Well, for me, currently, I'm doing my internship
Okay.
in a company here in Kenya. So, like, there's a project they are working on, like, it's ongoing already. It's about creating app. That app is used by a certain group of people. One, they are volunteers who teach at certain schools. So it's a let's say it's an organization that uses the app. The organization has volunteers, it has people who collect, how do you call these groups of maybe women or men that collect money and share at the end of the year? How do you call those
Is
groups
it
in
like
your
all
country?
these loan? It's not loan. Like all these people that does contribution. Is it like
Yeah,
oh
they
okay,
contribute to get and later share out.
oh okay,
Yeah, so the organization goes out into groups. It's then the groups enter their data and all that. It recruits volunteers who want to volunteers into school, and at the end of the month, they are being paid. So in that process of one of the members going to like each county, recruiting members, entering their details. So you'll find that there are, let's say, 100 people who have gone to recruit members. Let's say 100 members are being recruited at one time. So the database may like crash or like it may have an issue. So instead of immediately rejecting the request, the system could place incoming validation requests into a queue so that the application enters into a queue into the database one by one. Yeah.
Thank you. Thank you very much. Andrew, do you have something to share on this? Hello, Andrew. Hi, Andrew. If you're speaking, I don't we can't hear you. Hello, Andrew. Can you hear me? Okay, okay. He's trying to connect. While we're waiting for Andrew, okay, there's a question in the chat. It said, "Have you had to upgrade a running system, kind of like hot code loading? How did it go, and how did you also manage to maintain the state of the running process?" Okay, please, which of the speaker would like to throw more light on that? Zain, Tia, Stacey, anyone? Okay, can anyone hear me?
Yeah.
Oh,
Yes, I can hear you.
okay, thank you so much. So the question was that, have you ever had to upgrade a running system and kind of hot code loading? How did it go, and how do you also manage to maintain the state of the running process? So Zain, yeah,
Hello, can you hear me now?
yeah, we can hear you, Andrew.
Okay. The the other question you asked,
Okay, for the real
do you
world
mind repeating?
experience. Okay, the real world experience.
Yes.
Okay, so the real world experience is for you to share your experience on a failure your team encountered, and what lesson did you learn, and how did your team go about it to respond? How did your team respond to it?
Oh, okay. I I transitioned to Elixir quite recently. I think a year and a half ago. But before that, I've spent almost a decade with JavaScript. So I've not had the opportunity to build a production system with Elixir yet.
Okay, but on
But
JavaScript,
in JavaScript,
you can share your experience
yes,
with JavaScript.
yes, I'm going to share my experience with JavaScript, and
Okay.
I really appreciate what other speakers have said about Elixir. I've read them online on test, but I've not experienced it. But I know I've experienced it to the nearest picture. So for JavaScript, we all know that JavaScript is a single threaded runtime. So what that means, so when there is an issue, is not as isolated as Elixir. When there is an issue, even the part of the JavaScript that is not concerned also crashes. But in production, there is this package you call PM2 that monitors the process so that when there is an issue and there is a crash, PM2 detects that failure and restarts the whole process, which is like fault tolerance. But the only problem is that in production, when we notice an issue, we can have like within a space of few seconds to 1 minute, we can have a bunch of clients calling us that their system is not working. And when you now SSH into the terminal to check what is happening, you see the node server trying to restart because a lot of things are going on. So the node server trying to restart might take a couple of seconds. Yeah, a couple of seconds. It's not always up to a minute, but a couple of seconds. And that split window seconds can you can see like 4 or 5 times tell you that your system is not working because the Node.js is trying to restart. But in Elixir, things are a bit different. If I try to make a system request and there's an error, it doesn't take down the whole server. It This one now I've tried it on the personal project and I've seen it working firsthand. When there is an issue, one of the things I've done locally is that I intentionally connect to a database with the wrong credential. The server doesn't crash. I just see a bunch of logs telling me your database is not connecting, your database is not connecting. It just keeps trying to connect and it's just losing that. But once I put the right credentials, once I turn on my database server locally, it just connects automatically. If it was JavaScript, I didn't touch any code file because if it's local, if you touch your code file, not one can restart it. I didn't touch any code, I didn't touch any file. I just tampered with database settings. If it was a JavaScript server, as soon as I tamper with the database part is the part that I just tampered with. But because I tampered with database settings, the whole server will just crash and it can't restart. I mean, because it's local, so there's no PM2 any stuff locally. It just crashes and stays there. But in an Elixir or a Phoenix setup, once I tamper with database, like I turn it off from my local system, you just see the log that your database cannot connect, database cannot connect. But as soon as I turn it on, it just automatically connects and everything is okay. So that's one real life experience I've seen with JavaScript that even made me to love Elixir the more. I'm not saying JavaScript not an awesome platform, but this feature I just mentioned now is for me is a killer feature in Elixir. And I believe every other language are trying to borrow a leaf from that. But it's going to be hard for them because the difference with Elixir is that this was part of the features they had in mind when they were building it. So they don't need any external help or anything. It's inbuilt from the very foundation. So other languages are trying to copy that into their language, but it's difficult for them because this was not the original. It was not the original blueprint when they were building it. So that's my experience. I can say with Elixir on my real life
Okay,
with
thank you.
failure.
Thank you so much. Thank you very much. So we have a question on the chat. So before I ask my fourth question, I would like for us to look at the question on the chat and see how we can provide advices on how on or real experience on how you'll have gone about it. So the question says, have you ever had to upgrade a running system? I don't know, most of us that have used Elixir on production, I think most of the time we have had to upgrade or a running system. I have me myself, I have had to upgrade a system that is already running. It's already running and you have to upgrade the system, kind of like a hot code loading. How did it go? How do you manage to maintain the state of the running process? Who wants to X with that? Who wants to help with that? Tai? Zain?
Yeah. So so yes, this is one of the most powerful aspects of the Elixir or Erlang ecosystem. So, in my experience, in a standard stack, deployment usually involves blue green or rolling update where you sign up new containers and kill old ones. That works, but it's fundamentally a replacement strategy. With the beam, we can leverage hot code loading, updating the code inside a running process without losing its state. So it is liberating for high concurrency systems, especially when managing long-lived connections like web RTC sessions or real-time game states. Instead of dropping thousands of active connections during a deployment, the system allows the new code to take over while the existing state persists in the memory. So while this capability sounds to be powerful, but it requires discipline. The main challenge which I have faced were not the technical limitations of the VM machine, but rather version capability. So you have to ensure that your data structure mean the state which you are maintaining, remain compatible between the old code and new code. We usually mitigate this through version gen servers, which ensures our state handling is resilient to schema changes, and other one is careful state migration. It means if a structure changes significantly, we write transformation functions that run as part of the code swap. So, hot code loading changed how I think about upgrades. It moved the focus from how do I minimize downtime during a restart to how do I architect my state so I can evolve alongside the code. It turns deployment from a high stress event into a standard part of the system's life cycle. So usually the state and we persist or the gen servers usually keep its state in maps or structs in memory, and the logic is usually swapped through the change code function which is triggered. Yeah, these are the things which I have till now experienced. Yeah, that's it.
Thank you so much. Thank you so much, Zain. Ty, do you have an experience you like to share, or Stacy? Or
Yes, I also worked on upgrading release system with minimal changes since our application had long running processes handling active requests and background jobs. Simply restarting everything was not always the best option. The goal was to deploy the new version while applying users to continue using the system. Before the upgrade, we carefully reviewed the changes to ensure they have backward compatibility. Any changes to process starts, any changes process to state or message formats were planned so that existing processes could continue working during the transition. For stateful processes, we used OTPs, built-in upgrade mechanism to migrate their state to the new version without interrupting their work. Handle database changes carefully by making them backward compatible. For example, we introduce new fields or table first, apply the application changes, and only remove old structure after confirming all nodes were running the new version. During the deployment, we monitored logs, matrices, and application health very closely. We also had a rollback strategy ready in case anything unexpected happened. Fortunately, the upgrade went smooth because we had tested the release thoroughly in a staging environment before deploying in production. One thing I learned in that successful code upgrade are less about the deployment itself and more about compatibility. If your process state, message formats, and database changes are designed carefully, you can upgrade a running system with little or no impact on users. Thank you.
thank you so much. Thank you so much very much. Stacy, Andrew, do we have any contribution?
Nope, I shared mine.
Oh, okay. Thank you so much. Um, so we're going to move to the fourth topic under this discussion. I feel like already a lot has been learned. So I hope we have been able to answer your question. I can't see your full name.
Yes, yes, you'll be able to answer it.
Oh, okay. Thank you so much.
Yeah, thank you.
Thank you for the question. I feel like the question did not just help you; it's help every other person. So if every other person have a question, you can drop your question on the chat. I would read it out for the speaker, or you can unmute yourself and say it by yourself. So the next point we'll be discussing on is, we know nature moved from from JavaScript to Elixir, and I know some of the speakers are not just only in Elixir, some of them also move from somewhere to the other. So we're going to be dealing with probably where, if you are a full Elixir developer or you're not, what is your how has your preferred language, so how has your preferred language or framework or platform influence the way you build fault tolerance system? So you are, if you are from Elixir, how has Elixir influences how you build fault tolerance system? So what has Elixir changed in you? I know most of us, there's this quote, or should I say there's this thing that people say on LinkedIn. They will say thinking like Elixir, writing like Elixir, and they were like the two, like there's two different dimensions, like both of them have two different ways. So if you're from Elixir or you're from JavaScript, how has it influence you in building a fault tolerance system? I know most of us have talked about the principles, the key designs, the what is Elixir. Yeah, all the speakers have dived into that. So I would like the speakers to dive more into how has their preferred language or framework help influence the way they build a fault tolerance system. How did they build it before, and what's changed by their preferred language? So please, any speaker can go first. Any of the panelists can go first.
Okay, I'll go first.
Okay, Stacy, thank you.
So my background has been on Node JavaScript, the JavaScript node, which is like popular here. So in Node, I learned that for you to build a fault tolerant system, it relies heavily on how you design your application. For example, I had to think about a proper handling using the try catch. You know it. Handling rejected promises and validating user input. However, in Elixir, I've noticed a very different philosophy whereby in Node.js, the focus is always on preventing crashes through careful error handling. But in Elixir, the philosophy is about failure is expected. Like failure will be there. So, like you really know failure is there, and instead of trying to prevent every crash, the system is designed to recover automatically. Yep.
Thank you so much. Thank you so much, Stacy. Okay, who wants to throw more lights on your how has your preferred language influenced the way you build a fault tolerance system? Zain, Tai, Andrew. Uh, hello, hello, Tai, Andrew, Zain.
Yeah.
Please, okay.
So actually, Elixir has significantly influenced how I think about reliability. So instead of writing defensive code everywhere, OTP encourages building systems from many lightweight, isolated processes. It means if one process fails, supervision supervisors can restart only that process instead of crashing the entire application. So there is a term which is generally used in Elixir ecosystem is called let it crash. It's here let it crash. People got confused. It doesn't mean ignoring errors. It means allowing isolated processes to fail safely while supervisors recover them automatically. So this philosophy was a mindset shift for me. Initially, it sounds risky, but it actually leads to simpler code because you focus on recovery instead of trying to handle every possible error in one place. So combined with supervision trees and message passing, it becomes much easier to build resilient systems. So these were all the factors which influenced me towards the Elixir ecosystem. Yeah, that's it.
Thank you so much. Thank you so much. Thank you so much, Zain. So, Tai, hi, Tai.
Yeah. So working with Elixir has significantly influenced the way I build Fault-Tolerant system. The biggest mindset shift is that I no longer try to prevent every failure. Instead, I design systems that can recover from failures automatically, as we previously discussed about the supervisors. So OTP encourages through process isolation and supervision trees rather than having one failure affect the entire application. Work is split into independent processes. If one process crashes or automatically restarted without impacting the rest of the system, that has taught me to design application with clear boundaries and isolated responsibilities. It also changed how I integrate with external services. I naturally think about timeouts, retries, circuit breakers, and graceful degradation because I assume external dependency can become slow or unavailable at any time. More importantly, Elixir has influenced me overall engineering mindset. Even when I am working with other technologies, I still think in terms of isolation, atomic recovery, observability, and designing for failure from the start rather than creating reliability as something to add later.
Wow,
Thank you.
thank you so much, thank you very much. I feel like that was really really impactful and a very wonderful experience that you have gotten from Elixir. So
Yeah, thank you, Talha.
thank you very much. So we are moving to the last question. We are moving to the last discussion for the day before we make it open. Yeah, after this last discussion, we'll make it open for 10 minutes. So for that 10 to 15 minutes, we all can ask. So the I feel like the speakers might even have questions they want to ask we that are on the call. So that 10 minutes every is an open discussion. Everyone can ask anyone question. You can call a particular speaker and direct your question to them for that 10 minutes. So before then, we are moving to the last question for today, or the last topic for today. It says, if you could give any developer one piece of advice for building more reliable and resilient application, what would it be? So if you're giving advice to another developer in trying to build a more resilient and reliable application, what would your advice be? So who would like to go first?
Hello?
Hi, can you hear me?
Yes, I heard your question. Can you
Okay.
hear me? Yes?
Yeah, I can hear you.
Yeah, all right. So in software, is a good thing to always use the right tool for the right job. You know, when you hear AI development and you bring a bunch of developers and ask them which language is good for AI development, almost all developers will say Python. And when you ask developers which language is good for web, they will just say JavaScript, like that, like that. The reason why they say this is because this language has features that are built for this particular problem domain. For Elixir is getting the popular traction, attention because of that fault-tolerance and reliability. Elixir boasts that apps that use Elixir for their web infrastructure, they boast of 99.9% uptime. And it's not just boast, like they've proved it. You know, they've proved it with how how you can use Elixir to spin up like millions of connections, and the hardware is still not used up. And that's why apps like Discord, Pinterest, WhatsApp are using Elixir. Even though some of them are using Erlang, but some are using Elixir because they are almost the same thing. So my advice to any developer is that um, if reliability, resilience, and fault tolerance is your major concern, like you want this application to always be available to process or request, or you know always available for stuff. I would tend to use Elixir, not just because I like Elixir, but because this was the major problem that Erlang and Elixir was designed to solve. Other languages, if you use them, you have to start bringing in external tools, external dependencies to get that to out of the box. Now, Elixir have its own downside. Elixir is not as performant as some low-level languages like Rust, C Sharp, and C++. If you are concerned about that, you can you can you can put Elixir as an orchestrator. You can be calling those other systems, but Elixir will be the one directing the calls to these low-level guys. So Elixir is always available to receive requests and direct those requests to those low-level guys. But Elixir is at the center of the infrastructure directing the stuff because Elixir is the one that have that fault tolerance inbuilt in it from the very first design. So my advice for developers would be go for a language that has this thing inbuilt in it, which is Elixir. So that would be my advice for any developer that is looking for resilience and fault tolerance, other features that Elixir have out of the box.
Thank you. Thank you so
Yeah, thank
much.
you.
Thank you so much, Andrew. Thank you very, very much. That's a very wonderful advice. So I'm going to pick the next person. So I'm going to pick Stacy. So Stacy, what would be your advice?
Well, I'm not I don't say much because I'm not so old in the industry. I'm like a newcomer who is catching up very fast though. So with all these talks, I think it has been about handling failures. So my advice will just be simple. Design your software, assume that something will eventually fail. Yeah.
Thank you very much. So Ty or Muhammad Ty or Zain. So who is gonna go next?
So my advice would be a simple one, which is always assume your code will fail eventually. This is the principle which needs to be keep in mind. It means that don't only test the happy path. Means don't always check the ideal execution flow where everything work as expected. So think about what happens when a service is unavailable, a database connection drops, or a user disconnects halfway through an operation. So building reliable software is less about preventing every failure and more about recovering from failures quickly and predictably. Yeah, this is my advice to other developers.
Thank you so much. Thank you very much. Ty.
Okay, so if I could give one piece of advice, it would be to design for failure from. Am I audible?
Yeah, you're audible.
Okay, okay. If I could one piece of advice, it would be the design for failure from the beginning. Don't assume your database, network, or third-party service will always be available. Instead, ask yourself what happens if this component fails. If the answer is the whole application stops, then that is not an area that needs improvement. Build system with isolation, sensible timeouts, retries where appropriate, good monitoring, and automatic recovery. Just as importantly, test failure scenarios instead of only testing the happy path. I have learned that the most reliable systems are not the ones that never fail. They are the ones that fail gracefully, recover quickly, and minimize the impact on users. So that is my advice for the developers.
Thank you very much. So thank you, and once again thank you to all the speakers. I believe that this talk has really been impactful, and very it has actually been very impactful and very wonderful. I don't know about anybody, but I would say about myself that I have learned a lot from each and every one of the speakers, and I feel like every other person would have learned one or two things from the speakers, right? So this talk has really been very awesome. So coming to the 10 minutes section where the speakers and everyone on this call, you can deliberately ask any of, if you have question, maybe question that has been bothering your mind, or maybe something you see other Elixir developer doing and you're wondering why are they always doing this, why are they always writing this in their code, is it necessary, what is the viewpoint, what is the importance of building their code system in this manner. You can ask any of the speakers, and if the speaker has question for the people on this call, they can also ask. So it's an open section now. Oh, so are we all saying we are good to go? We don't have questions to ask the speakers?
100%.
Okay, please go ahead.
I was curious. Between Erlang and Elixir, which of those two languages do people prefer, and why? Why do they prefer probably Erlang to Elixir or Elixir to Erlang?
Okay, so does any of the speaker want to answer this question? Oh, okay, let me just, I will, okay, Zain, you can go ahead.
Yeah, so this is a very common question which people generally ask. In my experience, I don't think there is a single language that's best for every problem. Every language has its strengths, but people choose majority people choose Elixir when reliability, concurrency, and fault tolerance are their top priorities. What makes Elixir different is that it's built on the Beam virtual machine, which was originally designed for telecom systems where downtime was not acceptable. That means many of the features we often add later in other ecosystems, like process isolation, supervision, and fault recovery, are built into the platform from the start. In Elixir, applications are composed of thousands or even millions of lightweight processes. If one process fails, it doesn't affect the others, and the supervisor can automatically restart it. That naturally leads to systems that are more resilient. Another advantage which comes to mind is the simplicity of the concurrency model. Instead of managing threads and shared memory, processes communicate by message passing, which eliminates many synchronization issues like race conditions and deadlocks. So, for applications like real-time communication, multiplayer games, chat systems, IoT platforms, fintech apps, or distribution services, Elixir allows developers to spend more time building business features and less time dealing with infrastructure and recovery logic. So, if I explain it to one line, uh, I can say that it's a value for money. That's it.
And I also want to add on it.
Hello?
Yeah.
Hello?
Yeah, and I also want to add why
Okay.
on why people choose Elixir over Adel.
Okay, yes.
So
Zain, sorry,
Elixir,
please go ahead.
people prefer Elixir because it gives all the strengths of the Erlang ecosystem while providing a more modern and developer friendly. Elixir runs on the same virtual machine and the same OT framework. Erlang is known for. What I really like in Elixir syntax and tooling system, the syntax is very clean, expressive pattern matching, and pipelines make the code easy to read. And tools like Mixx Unit and IX provide a great developer experience. I find that I can write maintainable code faster without sacrificing performance or reliability. So that is the answer why people choose Elixir over Erlang.
Oh, thank you. Sorry, I was on the call. That's why I've not acknowledged it.
Yes, and then please, when you want to pack your clothes, please pack my clothes too. Is bed
Thank you.
sheets,
Thank you very
all
much.
nights,
And one more question, one last question. Does the dynamic type system, does it affect your coding in any way? Does it bring any problems when you are writing programs because you have to use probably the dynamic type system? Does it affect how many bugs on your code and things like that?
Yeah, that is a great question. Dynamic typing does introduce some challenges, but I don't say it is a problem. It's a trade-off. One challenge is that certain type-related issues are only discovered at runtime rather than compile time. In large code base, this means you need to strong test coverage, good code reviews, and clear contracts between different parts of the application. On the other hand, dynamic typing allows developer to move quickly, write less boilerplate, and iterate faster. In Elixir, features like pattern matching, immutable data, and pattern matching in function heads help catch many errors early, even without a static type system. In my experience, reliability in Elixir comes more from good design, comprehensive testing, and the fault tolerance nature of OTP than from the type system alone. That said, I also appreciate static type system. They catch an entire class of error at compile time, which can be very valuable, especially in large teams or complex domains. So I don't think dynamic typing is inherently a problem. It just means you rely on different techniques, testing, clear APIs, and good architecture to build reliable software.
Yeah,
Okay.
further, I would like to add something here. Am I audible?
Yeah, you're audible.
Sure.
Right.
So for me, yes, dynamic typing can introduce certain risks, but those risks can be managed. It's a conscious design trade-off rather than a flaw. So dynamic typing means variable types are checked at runtime instead of compile time. This gives developers more flexibility and often leads to faster development and cleaner code. Here trade-off can be some type related errors are not caught until the code is executed. For example, if a function expects a map but receives a string, the compiler won't necessarily catch it. You will discover it during testing or at runtime. That's why in Elixir, good testing, pattern matching, function gods, and clear function specifications become especially important. They help catch mistakes early and make the code easier to understand. So, for me, yes, dynamic typing introduces some risks, but Elixir compensates with powerful language features and strong testing practices. Many teams find that the productivity and simplicity outweigh the downsides. Hope it answered your questions. Yeah.
Thank you. Thank you
Yes.
very
Thank you.
Thank you very much for that response. I believe that every
Yeah, yeah, we can hear you.
oh sorry, I think I've been speaking on mute. Yeah, I think I've been speaking on mute. So I said thank you for answering those questions. I would agree with both Zain and Tai. I think they have really elaborate why people pick Elixir. Elixir it's more simple to understand, and the compilation of Elixir code and the structure of Elixir code makes it more easy to read and assimilate. So most people would go for Elixir since Elixir already have all the features that Elan provide. So it's easier for you to work with Elixir than Elan. But some people will still go for Elan because of the years of trust that Elan has. Elan was the first Elan Elixir was coined from Eland, so it means like Eland is the origin. So a lot of people would prefer to go for the origin. Like WhatsApp now, it's using Eland. WhatsApp is not using Elixir. So that comparison, it comes to what the team is trying to achieve, will determine which language they would use and for what. So do we have any other question? Do we have any other question? Are we all good to go? I will take only one question. Does the speaker has any question, or do anyone on the call has any question?
Yeah, we can hear you. Nature speaking.
Okay. So are we all saying we are good to go?
Yeah, we can hear you. It's only Nani whose network I think it's bad. She can't hear us. I
Oh,
think you can just talk.
okay. I can hear you, people. I can hear you, Stacy. I was just asking if any other person have any question, but I everywhere is quiet. So okay. Can
There's
anyone?
someone. I don't know if you can hear him. For me, I can hear him on my side.
Oh, can everyone hear me?
Yeah.
Yes, can hear you.
Okay, thank you so much. So I can hear Stacy, and I can hear what Muhammad Zain said. So I said, is there? I'm guessing that we don't have any question, because I was saying I was going to take the
I
last question.
I have a very small question.
Yeah, please go ahead.
Yeah, my question is how to pronounce your name for me.
Okay. So okay, my name is Ijeoma. I don't know. Is it easier to pronounce?
Can you please slowly pronounce it?
Oh, okay. Ijeoma. Ijeoma. Okay, if you can't pronounce that, you can pronounce Benedicta, right? Can you pronounce Benedicta?
Okay, Ijeoma.
Yeah, Ijeoma.
So, Ijeoma. So, can you introduce yourself because I think we missed the first 5 to 10 minutes.
Oh, wait. I thought I did introduce myself.
I think so. But we missed the starting 5 to 10 minutes.
Oh, okay. So, once again, thank you to all the speakers. You guys did an awesome job in explaining to us what it takes to build a fault tolerant system. So, my name is Ijoma Benedicta Uwabunkeonye, which is my surname. I'm an Elixir developer. I think I think it's almost 3 years plus now. I've been an Elixir developer, but before then I was Node.js. Yeah, I was from Node.js, so I transitioned to Elixir because of work. But after a while, I got to understand the intake of what the language has to offer, so I stick further to learning and growing myself in Elixir. And I opened a YouTube channel to try to teach about the language, but I am not really good in teaching. So I didn't really go further with it, because I do love imparting and I love Elixir, but I felt it would have been better if I could get people to share their own intake on Elixir, and that was how the community Elixir Naija came into existence. Because in Nigeria here, we have a lot of Elixir developer. Not really a lot. We have few Elixir developer, but there was no identity, so we're not able to know, are you an Elixir developer? So I was like, why don't I find a way with every other person to create a community where we can share and talk about Elixir, since most of us have one good thing in common, which is Elixir. So that was how the Elixir Naija Community came into existence, and that was in December 2024. So till December to date, we have had so many talk from developers in Brazil, Pakistan, mostly from Brazil, but I think, yeah, Brazil and Kenya. I think this is our first talk where we're having developers partner from Pakistan and Kenya and Nigeria. So thank you every one of the panelists for making yourself available to be on this call today. It has been an awesome call, and I believe everyone on this call has learned one or two things. So I am just Ijeoma, an Elixir developer that is so much into the language and so much into growing and expanding. So thank you all. I hope I
Yeah,
was I hope I was audible.
yeah, we've had you.
Oh, okay. I think is nature trying to say something, because on the chat I see like I think nature is trying to say something and we can't hear nature.
Yeah, he was speaking.
Oh, why can't I hear him? I wasn't not able to hear him over here.
Yeah, he's talking, but you can't hear him. But us, we can hear him.
Oh, I okay. I think I saw the reason. I think I muted him by mistake in my side, so I think that was why I was not able to hear him.
Oh, okay. So I was trying to answer the other question that was comparing Elixir and the rank.
Oh,
So I
okay.
just wanted to say Elixir is the child of the lang. You know, when you do class OOP, parent and child. So that means all the properties that a lang have, Elixir have them. But it's not all the properties that Elixir have that a lang have. So talk about things like meta programming, macros. That's an Elixir thing. A lang is not aware of that. Talk about things like pipe operator. That's an Elixir thing. A lang is not aware of that. But talk about things like supervision, fault tolerance, processes, things that OTP have. Those are Elang's features. Elixir have all that. Big thing, because it came from Elang. So for me, I prefer Elixir because, just as the previous speaker said, the syntax is more friendly. The syntax is more friendly and easier to reason about. The day I saw a single function to multiply two numbers in a lang, I couldn't make sense of it. I was like, what's this? Like, it's not intuitive enough. But people still use it probably because that's what they've been used to for years and they just prefer it. But if you call a new developer, a new engineer, and just drop the two language, I strongly believe that they'll go for Elixir. So it's just a matter of choice. But I believe new age developers will prefer Elixir to a lang. And secondly, it's better to go for a language that have all the things that the previous one have and also added features. So yeah, that was what I was trying to say on this one.
Oh,
Thank
okay.
you.
Okay, thank you so much. Thank you very much. And I'm so sorry that I
Ijeoma,
muted you. Yeah?
question. Like, do you guys have like the way you started this Elixir Naija? I think it was a good idea, bring people together and all that. And in terms of jobs, do you people know groups or have groups or communities like where one can get? Because literally in our like here, people like do the popular languages like Node.js and all that. So you find that Elixir, like for you to get one, I don't know, I think maybe if you get a remote one or two, yeah.
Okay, thank you, Stacy, for that. Currently, right now, I most time just try to, if I see job on LinkedIn or Elixir forum, I just try to post it in the community. But we are, I think Elixir forum is aware that an Elixir community exists in Nigeria, and I've been talking to so many other communities in Brazil, communities in UK, United States, and so many other small Elixir communities. Some are not small, some are big. And this year, I think this year is one of the greatest year when Elixir has so many communities and so many activities going on. Like this year, Elixir has one of the highest, I think Elixir will have one of the highest top conferences going on for developers in globally, because from April to December they have like various conferences in US, UK, Europe, and everything. I don't know about the Asian countries, sorry, because I haven't seen anything come up on the Asian country. But from Europe and US, I see that the Elixir community is trying to gain that momentum, trying to gain that recognition. So I believe that with higher recognition and higher momentum comes with companies now leveraging Elixir and saying, oh, this is why we want to use it. And with higher companies leveraging Elixir, it makes the job opportunity in Elixir expand, because currently right now the major issue a lot of developers that are doing Elixir face is the closed of the job opportunities. The language is beautiful, but there are less job opportunities because of fewer companies are using it. So with the expansion of the language and more publicity about the language, we are hoping to get more people coming into the market and say, oh, I want to use Elixir to build my system, and that will open more room for developers to get recognition for what they do. So I think Stacey, sorry, did I answer your question?
Yeah, I understand.
Okay, so thank you all for being here, and this has been a wonderful section. So we try as much as possible to have a section as much as we can, because I believe like the greatest way you can learn something is by observing and doing it. Observing is looking at people that are doing it and you doing it yourself, and this is what the community have been striving to do. The community have been striving to grow one way or the other and improve themselves individually and as a community. So thank you. We are so happy to have you on this call today, Stacey. Ty, can you help me with your name pronunciation? I think I've been pronouncing it wrongly throughout this call.
Yes, it is Talha.
Sorry, can you pronounce it?
Talha.
Elha.
Talha.
Oh wait, your pronunciation, your name is Elha.
Talha. Tal Tal
Oh,
H.
okay, Talha. Oh, okay, Talha.
Yes.
Oh, okay. So Talha, we are very, very happy to have you on this call. Thank you, and Zain. Zain also, thank you for being on this call. Every Hi Zain.
Hello.
Yeah. So I'm saying thank you for being on this call, and for everyone,
Yeah,
and
yeah.
Andrew.
Thank you for having me here. It was a nice experience.
Thank you so much. And Andrew, thank you so much for being thank you for being our speaker. Andrew has really, really helped a lot in the growth of this community. Is a Andrew is a stand-in speaker. Why I would say is a standing speaker is that Andrew is someone I can always go on his DM and say, Andrew, please, I don't have speakers for the next talk. Please, can you handle it? And he would really, really give justice to that talk. So thank you, Andrew, for all you do for this community. From me and everyone in this community, we are saying a big thank you. And thank you to every one of our awesome member for always showing up. Thank you, Kato. Thank you, Messi. Thank you, Smui. Maria, I think this is the first time we're having Maria on this call. Thank you, Maria, for coming. And Lee, thank you for your question. I don't know if your name is Lee.
No, my name is Nuku.
Oh, no, cool. Okay.
Yeah, Nuku.
Oh, Nuku.
Yeah.
Okay, Noku, thank you. Thank you for joining. We have David. David, thank you for coming. We have Karim. Karim, thank you for coming. And I think that's all. If I do not mention it, oh my god, I'm so sorry, Smui. Smui, I am really, really sorry. I did not pass your name intentionally. Smui has also been a very long member of this community. Even though he is from Ghana, he has always tried to show up in community activities, and I've always shared his input and try to find way for the community to grow. So thank you all and have a wonderful day, everyone, and happy weekend. So we have come to the end of today's call. Thank you so much. The talk was actually interesting. Oh, my back hurts.
Congratulations, but they do me mad.
Yeah, so because your TV almost never make me hear everything I want here, and you know go off your TV or lower for 1 hour. When Jesus say, "Can't you people fast for 1 hour?" Now you they talk to. Can't you people fast?
You don't see clothes don't dry. When you go cook pack. No, now you go.
The clothes don't dry.
My clothes one hand.
Who?
Can't go put wet
Who be that?
clothes. Mommy no shower.
She can't go put her own wet
Wet
clothes.
clothes. Can't go hang am
The
there.
clothes come, your clothes come wet
It's
now.
not wet. That is rubbish now.
Why she no pack the clothes? Even Aisha clothes to wet.
Everything. Even that clothes where I wash now, it don't go dry. Just small. But it's still don't wet.
Why she no? Me I dey pack my clothes too. If I see somebody clothes don't dry, go pack your clothes put inside bath.
You go pack and come out hang your own.
Okay, I dey go outside.